Hello again. Now we're going to be working with cubes. So in our problem it says a cube is a special rectangular prism where all the edges have the same length. In each of these parts it says find the lengths in terms of s. I'm just going to be using x because my s's aren't great because I have bad handwriting. So it's just going to be easier to work with x. So let's get started. Find the formula for the volume of a cube with side length s. Well, from our previous problems, we know that the volume of a prism, specifically a rectangular prism, is length times width times height. Or, for any prism, it's the area of the base times its height. So, if I were to follow that same logic, its length would be x, its width would be x, and its height would be x. Or you would have x to the third power. And that's just part A. Very simple. So, surface area. Again, from the previous problem, we know that it's the sum of all the areas of all the faces. And we know that each opposite pair of faces will have the same area. So it's really 2 times each pair of opposite faces. Or the areas of each opposite face, I should say. So we have 3 pairs of opposite faces. WZSV and XYUT would be one pair. Another would be WXTS and ZYUV. And then we would have WXYZ STUV. Each of these, since they have the same dimensions, has an area of x squared. Just like that. And if I do some simplification, that means that there are 3x squareds. And if we multiply by 2, the surface area is 6 times x squared, which is a very simple formula for the surface area of a cube. Now, find the formula for the length of SY in the diagram. So, this is kind of, if we repeat the process that we did in the last problem where we found, AG, we can do something similar. So I should start, how I initially found that was by creating a rectangle, or in this case a square, and found the length of the diagonal of that top base. So W, Z, Y, X. And I want to find the diagonal from W to Y. Well, if I know that this is X and this is X, just be careful, it's different from this one because this is like capital, the point, whereas these are the sides. And that means WX, or WY I should say, has a length of X times the square root of 2 by Pythagorean theorem. We can also note that since it's isosceles and it's a right triangle, it's a 45, 45, 90 triangle, and we would get the same ratio. So from there, since I know what WY is, now let me try to find SY. Like that. So that is a triangle that looks like this. It is a right triangle because that angle formed by W and S is 90 degrees. I know that wy is x times the square root of 2. ws has a length of x. So now I need to find sy. So if we use Pythagorean theorem, we have x squared plus x times the square root of 2 squared equals sy squared. So x squared stays the same, plus we have x squared is x squared times the square root of 2 squared is 2 equals sy squared. Combine our like terms and we have 3x squared equals sy squared. And by taking the square root, we have x times the square root of 3 equals sy. Hence, we get our answer, where this sy is the space diagonal of the cube.